Alright guys, this video is going to be a little bit of a review over a lot of stuff we've just done with functions here, okay? So not going to hit everything that we've done, but try to hit the key points. So let's start off with a little bit of domain and range. Our favorite topic, right? So looking at the domain of a graph. So if I start off with here, and maybe I draw this graph right here. Question is, what's the domain and the range of the graph? Okay. Well, real quickly, just a reminder that notice how the graph, when x is negative, I've got a graph that goes with it. When x is positive, comes down here when x is 0. So my domain is going to be all real numbers denoted with this little symbol here. In my range, so my domain is all real numbers, just all real numbers, anything I want, positive, negatives, or 0. My range, however, if I look, and maybe I should write that in a different color, my range, now I'm looking at the y-axis. So I'm saying, hey, when y is negative, shoot, there's no graph down here. I don't see a graph down there. Okay? When y is positive, though, see how I've got a graph up here when y is positive, and over here, graph looks like it comes down to 0. So my range is going to be all real numbers greater than or equal to 0. What that means is 0 or any positive number. Okay? So just as one quick reminder, let's look at another example. Let's take a look at a function. Let's do f of x equals, and let's do the square root of x minus 4 plus 5. Okay, so a couple ways I could find the domain and range of this function. One, I could remind myself what the domain and the range of the square root function are, and that's definitely a good spot to start. What I'm going to do is I'm going to remind myself of a picture here. So I'm going to go to Desmos. I'm going to graph function. You could do this on your phone or on your computer as well. X minus 4 plus 5. Let me make sure yep. Okay, now take a look at my graph here and adjust my picture so my scale is 1 on my graph paper. And I notice, hey, look at this. Let me get something to write with here. I noticed that, hey, look, my graph, what we would say, starts here, and from here on over, all these x-coordinates, there's no graph that goes with it. However, from here on over, there is a graph that goes with it on the x-axis. And very similarly, on the y-axis, from 5 and down, there's also no graph down there. There's only a graph from here up. So my graph is there. So color coding this helps me a little bit, and I can say, well, my domain, so my x coordinates, look like they go from 4 and above, so all real numbers greater than or equal to 4. And my range looks like it's from 5 and above, so all real numbers greater than or equal to 5. Okay? Alright, so real quick review on domain and range. We're going to move on and look at a few things we've been working on recently here. So let's take a look at some input-output tables. Looks like a table we just did here in class on Thursday, Friday of, well, it'll be last week when you're watching it here. So, directions number 4, we're going to take a look at. List the information that is missing from each table. So starting with table A. Well, I got these outputs here, -5 and -6. Remember my change, my difference column, my delta symbol. So remember that's delta, and it means my change, or we might say difference. However you want to think about that. So what I always think about is from -5 to -6, I'm adding this number. Okay, so I'm adding a negative. Maybe instead of saying -5 plus -1, maybe you think about -5 minus 1. It's the same thing, right? So -5 minus 1 gets me to -6. So what number would I subtract -1 from to get to -5? Okay, so if you picture your number line and how that works, we know, hey, that'd be -4. But also realize I'm subtracting going down, so from here, I could go back up by adding. So -5 plus 1 gets me to my previous one. Okay, and we can start to see our pattern here a little bit. But we always want to double check our answer. -2 minus 1 is -3, -3 minus 1 is -4, etc. Alright? So, table B. Okay, so now I've got my outputs, but I'm missing my change. And here's where I guess it doesn't matter to me how you do it, but I saw two different things happening in class depending on how you want to think about it. And the textbook emphasized taking the second output and subtracting it from the one you're looking at, or I should say the next output. So 4 minus 3, that number goes here. So we'd say that's 1. 4 minus 3 is 1. Some people said, well, instead of doing that, I just want to ask myself 4 plus what number is 7. Okay, that's fine. I know 4 plus 3 is 7. It doesn't matter as long as the numbers are something doable where you can figure that out quickly mentally. So if you get into big numbers, and I'll look at an example here in a second, we'll want to look at doing the subtracting. So 12 plus 7 is 19. Okay? Table C. Change here is 5. They only gave me one output, so if I go from 5 and add 5, I'd end up at 10. 10 plus 5 is 15. 15 plus 5 is 20. And then again, backing up here, go down to 0. Okay? Number 5. Which tables can you generate using a linear function? And then write that function. All right. Well, we talked about the change column in class and how that represents the slope. So remember that this is telling me the change in the y. So my change in my output. And when we're talking about slope, we're talking about rise over run, or change in y over change in x. Okay? So my change in y is here in table B is not constant. It's a different number. So as I move along my x-axis from 0 to 1 to 2, etc., I'm getting a change in the y that's getting more and more. So I end up creating a kind of a curve, what we call kind of a parabola. It's a quadratic equation instead of a linear function. For those of you watching the Olympics at home, parabola looks a lot like a half pipe that you might see in the snowboarding or skiing Olympics. So table A. -1, I got the same, a constant change, a constant difference. So my slope is -1, so that'll work. And according to directions down here, I'm going to write that linear function. So I know my linear function is going to be of the form, f of x equals mx plus b. So my slope is -1 plus, and then I want to look at when x is 0, what is my output? So x is 0 here, my output is -3, so I'm going to do -1x plus a -3. Some of you might choose to write that as just -x minus 3. That's fine too. Doesn't matter. Okay? Table B we said wouldn't work. Table C, we're going to take a look at this. And I'm going to say, well, f of x equals mx plus b. So I'm going to go right to my change column and say, well, that's my slope, right? Sure, kind of. This case, we have a difference from this table to the table C to table A. Table C, my inputs here, we're increasing by 1. So the change in the y, or change in x, my run, was 1 each time. That's why my slope was -1 over 1. Okay? Here, my slope is 5 over, what's my change over here? Well, my change is 2 all the way down, right? So my slope is 5 over 2. Some of you might want to write that as 2.5. I'm just going to choose to write that as my fraction. 5 halves x plus, and then what's when x is 0, what's my input 0, what's my output, and that's also 0. So I'll do plus 0. Do I have to have the 0? No, of course not. 5 halves x, that would work too. If you include the 0, it's not wrong. Alright, so let's take a look at another situation. Let's go ahead and look at, I was going to do this cell phone plan, but let's slide up and we can do the cell phone plan. Table shows a monthly cost of a cell phone plan based on the number of minutes used. Okay, so some of your some cell phone plans still do this. It used to be more of a common thing in the past, but some of us still have cell phone plans like that, and they're charging us per minute. Okay, so what is the monthly cost for 20 minutes of calls? That's the question. So identify the question. I even like to underline it. Monthly cost for 20 minutes worth of calls. Let's look at my table and make sense of the problem. Minutes used, okay, so 1, 2, 3. I want to know what the output is when this is 20. My monthly cost for 1 minute is here, 2 minutes, 3 minutes. So I'm going to add my change column here. Okay, so as I do a little math here, I can see, well, shoot, they're all increasing by 15 cents. Okay, so if I went back to, and I added 0, so let's say I put a 0 here, what would my output be? Well, instead of adding $30.15 plus 15 cents to get $3.30, I'm going to subtract and back up. So this looks like it's going to be $30. So my input is 0, my output is $30. So in the context of this problem, that just means if I make no calls at all, and just have this plan, it's going to be 30 bucks. Okay, so let's write an equation for that. Okay, so let's do C of M. All right, so why did I use C of M instead of F of X? Well, it's just, this problem just has a little bit more meaning to it. So the cost is a function of the number of minutes. Okay, so I just named my function cost, or I used C, and then said M for the number of minutes. And it's going to be 0.15, so 15 cents times the number of minutes plus 30. Okay, so my calculator, I punch in, well, what's 20 minutes? Okay, well, 20 times, 2 times 15 is 30. So when I do 20 times 15 cents, 0.15 times 20 plus 30, I get $3 plus 30 and get $33 total. Okay, solve the problem. Oh shoot, that's right, it was multiple choice. Look over here, and B is my correct answer. All right, let's take a look at one more problem here. So let me explain the context of this problem real quick. We're talking about a big machine that drills a hole in the ground, and we're drilling for oil. Okay, so this is very similar to drilling a well in the ground for water, or something where you're trying to get really deep to access natural gas, oil, water, something that we can use on the surface of the ground. Okay, so if you've never seen one of these, maybe you can YouTube it and watch a quick video of how it works. But it drills a hole straight down hundreds of feet into the ground. Okay. What volume of earth, so as the drill is running, it's pulling dirt up out of the ground. What volume of earth does the oil company remove when the hole is 700 feet deep? Okay, so I'm going to do a little bit of math here and look at this as I add my change column. Say, okay, well this is 1,257 is my change, etc. So to get to 700, a couple things I could do. I could add 2 more 1,257s. I could do that. I'm noticing that I'm just multiplying times 1 times 2 times 3. Okay, so I could take 1,257 times 7, all right, and end up with, 8,799. That would work. Okay, several other things I could do. So here's just an example of a table that we can move forward with some applications, but definitely gives us a little bit of practice with our change column, our delta column, and applications with our tables.